This fifth workshop covers web indicators. For these indicators, we're going to create them and then analyze them. These are by far the most complicated indicators to work with because they involve the creation stage as well as the collection stage and processing stage. We're going to look at the example of Wikipedia. We're going to get our own Wikipedia data and we're going to calculate the MNLCS and EMNPC for Wikipedia citations gathered from the web with Webometric Analyst. So this covers stages 2, 3 and 4. Making the web queries, submitting the queries to Bing in this case, and calculating the indicator values. First of all, we need to create Wikipedia searches. We need to use Bing to search for pages that cite academic articles in Wikipedia. We're using Wikipedia citations to illustrate the process needed to gather web citations, but similar steps work for other web indicators such as online syllabus mentions. A citation from Wikipedia might be used as alternative evidence of educational, academic or informational uses of a publication, whatever reason has been used to put it in Wikipedia. First stage, making the web queries. We're going to search for Wikipedia citations. We're going to use a Wikipedia site-specific query, and in Google and Bing, these can be used to identify citations to articles from Wikipedia articles. If you try this in the web version of Bing, it doesn't work very well, but in the Bing API, which we're going to use, it does work well. But you will need to test this if you're going to use this for an evaluation, because search engines change periodically. So by the time you try it out, it might no longer work in the Bing API. We need to search with the Bing API with a high precision query to make sure that we don't match pages that don't really cite the paper we're interested in. From experiments by Cave and Kusha, the optimal query will contain author last names, the title of the article as a phrase search, the journal name as a phrase search, and the publication year. If you combine these, then there shouldn't be any false matches usually from a Bing API. And here's an example. This is a search for Bing or Google with the last names, 3 last names of 3 authors, then the title of the paper in quotes, then the title of the journal in quotes, and then the publication year, and then finally site:/wikipedia.org/wiki, and the final bit ensures that the search engine will only return matches from Wikipedia that are standard Wikipedia pages. So it's a clever search engine search to match citations to specific journal articles within Wikipedia. For example, if you search this in Bing, if you get the same results as me, you'll find one web page, and if you look at the contents of the web page, you'll see that this article by Kondo is cited. And there we go, right down at the bottom of this Wikipedia page in the list of references, number 17 at the time I tested this was the Kondo paper. So it is a correct match. It is evidence of a Wikipedia citation to this specific paper. How do we create Wikipedia citation queries? And this is a problem because we need one for every article. And say we have 500 articles, that's 500 searches we need to submit. Well, Webometric Analyst will do this for us. If we have a Web of Science, Scopus or Dimensions article, we can feed it into Webometric Analyst and it will build the searches automatically for us. To do this, from the main interface, select Make Wikipedia Searches for Scopus, Web of Science or other journal articles or books from the Make Searches menu, and then select the folder containing the publication information, one of the 4 files we've already saved for Spanish chemistry of alcohol research case study, and then it will create files of Wikipedia searches. These searches will end in _wiki or _wiki.txt, as in the example below. Biochemistry, molecular biology, alcohol research, Spain from 2012. Here's the option shown in the Make Searches menu of Webometric Analyst, and you'll see there are lots of different make options around it for different types of web citation searches. And this is an example of a file of searches created by this option, and if you look carefully at this, you'll see lots of up to 3 author last names, and then titles in quotes, and then journal names in quotes, and publication years, and then cite wikipedia.org/wiki at the end. So all of these we need to search to Bing to count the number of matches to them. The next stage is submitting the queries to Bing through its API via Webometric Analyst to get the number of matches from Wikipedia. How does this work? This is a complicated bit. You need to sign up to use a Bing search key, a Bing API search key. If you sign up online, there's a link on the web page, the Webometric Analyst web page, to signing up for a Bing key. Then you can run the searches. It's a tricky process, so what you're signing up for is a Microsoft Cognitive Services key with permission to access the Bing Search API. Instructions are available on the website for Webometric Analyst, but it might take 10 or 20 minutes to get it done. Sometimes you're asked for entering credit card information, sometimes not. I think it depends on the computer that you're using. If you're not, then you're safe. If you are, then you have to be very, very careful that you don't sign up for them to automatically bill you. The last time I tried it, you could get the key without signing up for the automatic billing, but please be super careful if you do this, if it asks for your credit card information, and if you're at all concerned, don't enter your credit card and just use the files from Wikipedia that are in the workshop zip file folder, the cheat files with the link at the bottom. And if you feel at all unsure, just skip the Bing API searches part if you don't need to use this type of indicator. If you do use the indicator, then start Webometric Analyst, use the menu option to select a search engine, enter a Windows Cognitive Services key, that's the key you've got from Bing, and then to submit the Wikipedia queries, start Webometric Analyst, select Link Analysis Wizard from the File menu, enter your key in the wizard, click OK to close the wizard, so that's the wizard that we saw on the previous slide. Click Run All Searches in File button near the bottom right hand corner of the main web interface for Webometric Analyst, and select a file ending in _wiki, and then wait for the queries to be submitted to Bing. This takes a few minutes normally, and then repeat for the second, third and fourth files so that all the queries have been submitted to Bing. So this will get you lots of new files, some of which include the Bing results. So this is where the Run All Searches in File button is, on the main screen in the Web tab near the bottom right hand corner. And when you've done this, you'll get 4 extra files for all your original files with funny names like Bing 10 long results, Bing short results, Bing 10 long results raw, Bing 10 long results spam, and Webometric Analyst will know which of these files it needs to use to create the indicators. So and this is the one ending in long results, 10 long results. So how do we create the MNLCS and EMNPC for the Wikipedia citations? And remember that the EMNPC might be the best one for Wikipedia, because most of the scores are likely to be 0. We'll start Webometric Analyst. From the Reports menu, select Calculate MNLCS and EMNPC4, and then pick the Web Searches one or more files, structured file names, and select the folder containing the files. So we're doing number 4. And here is where it is. Web Searches. It's near the top of the Reports menu final section. The Reports menu this time is going to be much bigger than the Reports menus of previous times, and that's because it calculates 5 statistics where the previous times only 1 statistic has been calculated. And that's because it calculates the statistic. It counts the number of web pages, the number of web domains, the number of websites, the number of second or top level domains, and the number of top level domains that cite each academic article, and it gives a separate statistic for each one. So for Wikipedia, we're interested in the number of pages, so we would just use the first one. So I'd recommend using the first one unless you have a special reason to use another one, and that special reason might be there's lots of pages in the same website contain duplicate citations of some of your articles. And here's an example. These are the biochemistry, molecular biology, alcohol results for the world file, and you can see the geometric mean for the world file. It contains 5 rows, URLs, that's the pages one, domain sites, STLDs and TLDs, all very similar numbers. In fact, in this case, they're almost all the same. The last 3 are the same anyway. And again, we have URL and other versions of the MNLCS, and we use the sample version. And in this case, for Spain, for the biochemistry, molecular biology, alcohol research, the MNLCS for Wikipedia is below 1, so below the world average, but the confidence interval is very wide, containing 1, containing the world average. So Spain isn't cited statistically significantly below the world average. And we have the corresponding result for all the fields combined, which is called URL MNLCS. And we don't get a confidence interval for that because of the number of zeros. This is for the MNLCS indicator, which, remember, is not the best one for Wikipedia. The better one is the normalized proportion cited, which we have here is slightly above the world average 1, slightly above 1, but containing the world average 1 in the confidence interval for the biochemistry, molecular biology set at the end. And then the best one is the one that combines all the fields together, which is the EMNPC for Spain, all the Spain, so the 2 different fields for Spain, and that's above the world average of 1, but not statistically significantly above. So this is the main one to use. So EMNPC better than MNLCS for web indicators with a high proportion of zeros, a majority zeros, a strong majority zeros. Okay, so one final presentation after this one.